Roberto is a marine science with a Ph.D. in ocean remote sensing. As of 2010, he's based at the European Space Agency, Italy, first as a postdoc research fellow. Then he was acting as a technical officer on a variety of projects, mostly dealing with ocean salinity, ocean acidification, and now he's an Earth observation satellite scientist. His research interests are within the ocean remote sensing and climate change domains, specifically, as I said before, ocean salinity, carbon cycle, and ocean acidification. And so welcome, Roberto, the floor is yours.
Many thanks, Christine and the organizers. Thanks for having me, and I really regret of not being able to be with you there for this interesting panel discussion. I put my slides on. I would assume you can see them well.
Yeah, we can.
Very well. So, well, I got myself introduced already, so I will now concentrate on these ambitious goals of covering in about 10 minutes time ESA Earth observation activities, ocean science and climate. The angle I chose to cover this is through three major programmatic lines, and I will cover then the related ocean and climate activities. I will start with the ESA Science for Society, which is a big umbrella that covers scientific exploitation of existing and future satellite, ESA satellite mainly, which are then divided into domain. I'll focus on the ocean domain, of course. So I'll describe the ESA Ocean Science Cluster. Then activities together with the European Commission under the umbrella of this program known as the Earth System Science Activities Initiative. And then I'll focus very briefly on the outcome of a workshop that we had last November in ESRIN. Then I'll move to another programmatic line, which is the ESA Climate Change Initiative. And in that, I'll describe again very briefly, necessarily, the related Climate Change Initiative ocean projects. And I'll finish off with just a few words on the Copernicus expansion missions, and namely the Copernicus Image Microwave Radiometer SIMR. So let me start with these ocean science clusters. Within the science section of the Science and Climate Department, we focus activities per domain into these so-called clusters. Clusters are a portfolio of existing and upcoming domain-related projects. And this is not only a list of the activities that we have, it serves not only as a list of the projects that we have running, but also to collect all the efforts that are being devoted into this project in a yearly workshop or event that we organize in ESRIN. So here they are in turn separated into subclusters or subtopics domain. I'll start from ocean extremes and I'll go clockwise. Ocean extremes, ocean carbon, ocean role in Earth and climate, the ocean dynamics and air sea interaction, the coastal ocean and land sea interaction, and ocean health and biodiversity. And another way to look at this is through this metro-like representation, just to give you a nerdy touch into this. Whereas you have the various subclusters, the various topics here represented as metro lines. So we have ocean health, coastal, ocean dynamics, extremes, ocean carbon, and ocean climate. And you can see that each of the project interlinks in many cases with these subclusters activities, and this gives the feeling that this is intended to be really as an Earth system science initiative approach. And through that, we also want to favor synergy among these projects. And we have dedicated budget line also to have intercooperation and dedicated CCN to some of the projects within this cluster. Another collaborative way that involves not only ESA in this case is that with the European Commission and the RTD Directorate, under the umbrella of several flagships. We are involved regarding ocean under this Ocean Health flagship, which involves on ESA side the projects that are indicated in this cyan box. I'll spend just a minute to describe this initiative. It started already a few years ago upon agreement at very high level between ESA and the Commission, and specifically the RTD Directorate. And those are the funding lines that are involved: Horizon Europe and the Future EO on the ESA side, and several of the, I don't know if you can see my cursor moving, but several flagships have been identified covering several domains, and we are into this ocean health. And very soon we will have an additional activities covering more on the land-sea interaction and coastal areas. The idea is that there are parallel ITTs, parallel set of projects launched at both ESA and Commission level, and the applicants are requested to interact among these projects to generate a value that is beyond the extent of the single projects. I mentioned before that we had that we have a yearly gathering of all the activities per domain. This year we had this, last November in ESRIN, we had this joint ESA Earth System Science Initiative, in which in the ocean sessions, we had sessions dedicated to all these various subclusters that I mentioned before. We are now gathering a final set of recommendations. We have got two kinds of recommendations, general overall recommendation and then specific per topic recommendations. Those recommendations, as this has been done in the past, will then be the basis for the new set of projects that we'll be launching, both internally at ESA and in partnership with the Commission. And this, together with the outcomes of a dedicated study that is called the Earth Observation Science Strategy Foundation Study, will be then set scene for the upcoming ESA activities and specifically remote sensing of the ocean and climate. Let me just comment 1 second. One of the projects that we have that is really a manifesto of this Earth System Science attitude that we have, in this case, is a project of projects. So gathering all the outcomes and the elements that were funded in different projects, we are now aiming at bigger goals. In this case, the establishment of an ocean carbon budget from space under the framework of this scope project, and you can see in this very nice infograph that you have all the pools on the left side and all the fluxes and processes on the right side, and we have listed here all the various projects that have been tackling these various elements, in this case ocean salt and ocean health for the dissolved inorganic carbon part, the BICEP project for the dissolved organic carbon component, then Physioglobe for the particulate organic carbon and the phytoplankton carbon. And then if we go on the processes side, we had this Primus regarding primary production, and then ocean flux greenhouse gases for the air-sea interaction. All of these will be tackled all at once to have an estimate of pools and fluxes amenable from space, and collecting these into an estimate of the ocean carbon budget. If I now move to the element of the climate change initiative, this is dealt at the Climate Office in UK. And this is an overview of the various CCI projects divided per domain. We will focus on the inner line, on the ocean part. The CCI projects are aiming at establishing baselines of climate data record, each of them targeting a specific essential climate variable as defined by GCOS. And each of them is aiming at merging information coming from various satellite sources in the most clever possible way to then define this baseline of CDR for future scientific and climatic studies. If I focus on the 7 ocean ECVs CCI projects that you have listed there: sea level, sea surface temperature, ocean color, sea ice, sea state, sea surface salinity, and sea level budget closure. And I'll give you just a glimpse of some results on this. Over here you have just the primary production estimates out of ocean color CCI data sets. Over here you have a composite of SMOS, Aquarius, and SMAP CCI salinity project. And over here we have this very nice chart describing the activities at sea level budget closure, where they basically put together the estimates of the overall sea level, as in this green curve, is in black curve over on the top of here, to the sum of the various contributions that have been assessed into all these various projects. So the thermal expansion, and the glaciers estimation, ice sheets from Greenland and Antarctic, and so on and so forth, summing them up. And you see how close they are towards the effort of the sea level budget closure. I'll move now to the Copernicus context. In blue, you have the sentinels that are flying today. Into the same box, you have the sentinels that are about to fly under the so-called extension series, then the next generation sentinels, and I'll focus just 1 minute on this Copernicus expansion. Those are new Copernicus series satellites that are aiming at targeting a specific scientific aspect that have an operational interest, and I'll spend just a few seconds on SIMR. That is the Copernicus imaging in microwave radiometer. It's a multi-frequency microwave radiometer that is aiming at targeting polar oceans for what concerns us, trying to prevent the anticipated gap in L-band capability, being ready for a nice free Arctic, and outsourcing key variables of sea ice concentration and thickness, sea surface temperature, and salinity, all from the same satellite. The measurements are every 6 hours, no hole at the poles, and the outcomes are serving the various Copernicus services. This is the science data catalog that you can inspect to access the data, and I'll stop here, and thank you for your time.